Hi guys, welcome to my channel. So today let's solve yet other Leet code question. The description of the question is as follows: that a 3 by 3 magic square is a 3 by 3 grid with distinct numbers from 1 to 9 such that each row, column and both diagonals all have the same size. Fine. Given a row called grid of integers, how many 3 by 3 contiguous magic square subgrids are there? Okay, great. So we were given a 3 by some m by n grid, and out of this m by n grid we need to find all the 3 by 3 subgrids that are possible, and we need to check the condition for magic square. And given that grid is called magic square when the following conditions are satisfied. First one is every row element sum is equals to every call element sum is equals to diagonal 1 sum plus diagonal 2 sum. And second is it should contain every number from 1 to 9. Okay, great. So let's check the first example: 4384 9519 2762. So out of these, we know the first possible 3 by 3 grid that's possible is E on 3 grid is 4 4 3 along with 8, 9 5 along with 1, 2 7 along with 6. So if we check the row sum over here, for every row the sum is 15. For this row is also it's 15. For this row even it's 15. So let's check for column 9, 11, 15, 5, 12, 15, 7, 8, 15, and diagonal 6, 4, 10, 10, 5, 15, 8, 2, 10, 10, 5, 15. So this is our magic square, and we have every distinct number from 1 to 9. So first, my intuition would be to generate these grids. So for that, I'll just call vector int generate, and I'll just pass my grid along with start row and start column. So for checking if I could generate a 3 by 3 grid, I need to know the start row and start column. And I do not need n row and n column, because if I knew start row and start column, n row and n column would be start row plus 2 and start column plus 2, because it's a zero based index and we are including both start row and n row. So first I'll just check my row size is grid dot size, followed by my call size would be grid 0 dot size. I'll just check if my start row plus 3 is greater than row, or start call plus 3 is greater than call. In both of these cases, we couldn't generate an array, so I'm just returning the empty array because we are out of bounds of our grid size. And else, I'll just initialize vector grid, and I'll call it a name SQ grid. SQ represents square, and here I'll just start from start row. I'll just go tell row plus 3, sorry, start row plus 3. I plus plus. Similarly, I'll just start here at start column plus 3, j plus plus. So first, for storing the elements in the temporary row or in the current row, I'll just call a curr row grid. Sorry, I'll just need it as a vector. So I'll just push grid of ij over here, and after pushing this, that curve row will be pushed into SQ grid because we already deduced our curve row and we need to push it into our square grid. So it's fine. So we just generated our grid given the start row and start column. And having this done, I'll just also call a helper function. So this helper function will take the generated grid. So I'll just call it generated SQ grid. And after getting this generated grid, what I'll do is I'll just check if my SQ grid dot size is 0. If my SQ grid dot size is 0, then it won't be for sure become a magic square. And that could be 0 when my start row plus row is greater than row. I mean, if I am at this position, then 3 by 3 grid, a subcontiguous grid cannot be generated from this position. So then empty grid will be passed, and here that condition will be failed and will return false. So here also I'll just have now having this done, I'll just call checker sum that's equals to 0 at the beginning. Sorry, int max at the beginning. So this checker sum will contain the value that needs to be same across all rows and columns. And my I do not need to maintain anything. For int I equal to 0, I less than 3, I plus plus, int sum is equal to 0. This sum will be storing the sum that's present over all elements in the row. So here sum would be plus equals to SQ grid of I and j. And I'm just checking if this is my starter sum that I reduced. If my checker sum is equal to int max, then my checker sum would be equal to sum. Else, if checker sum is not equal to sum, in the case that I am having two rows whose sum is not being equal, then I'm simply return false. And also I'll just need to check other condition, that if my square grid of ij is less than 1 or square grid of I'll check that afterwards. That would be fine. Now for row we already have checked. Now I'll just check for columns. So first I'll start at first column. I'll move until all three columns, and current column sum is 0. So at the current column I'll just traverse through all the rows. Sum would be equal to SQ grid of ij again. And now also I'll just check if my checker sum is equal to int max. Checker sum would be equal to sum. Else if checker sum not equals to sum, return false. I'll also need to check diagonal values. I am calling this as diag1. For diag1 it would be SQ I1 is not taking. Okay. For diagonal 1 it is SQ grid of 0 0 plus SQ grid of 1 1 plus SQ grid of 2 2. And for diag 2 it would be SQ grid of 2 0 plus SQ grid of 1 1 plus SQ grid of 0 2. You got it why diagonal 1 and diagonal 2 are these values. So if I consider this contiguous matrix as a 3 by 3 matrix, then first diagonal would be 4 5 6. So this is 0 0th index, 1 1 index, 2 2 index, and this is 2 0 index, this is 1 1 index, 0 2 index. I'll also check diag 1 should be equal to checker sum, and diag 2 also should be equal to checker sum. So this is done. Now let's come into the main function. I'll have an ans here set to 0, and I'll also have row equal to grid dot size followed by call that's equals to grid 0 dot size. I'll just check for every row and every column So at every position, I'll consider that as my starting row and starting column, and I'll just check if my helper of generated square matrix will yield me magic vector or not. So this also can be considered within private itself. So here I'm going to use it in. So having this done, helper of what would we call this? Generate grid name start row and start column. Generate the grid name is grid itself, start row is I, start column is J, and we'll just return the answer. So compilation error. What's that? Acha, it's tag 2. Acha, here once everything is done, we need to return square grid that we generated. Okay, so this shouldn't be constant because we are generating it on the go. It's working fine, but I guess we missed one more condition, and that's I'll just call it check matrix. And vector grid int, again I'll just call it grid, and what I'll do is I'll just have vector int all numbers 10 and 1. I'll also check for int I equal to 0, I less than 3, I plus plus, followed by j equal to 0, j is less than 3, j plus plus, all number of all number of grid of I. First, let me check if my grid of I, j is less than 1 or grid of I, j is greater than 9 will return false, else we'll call all number of grid of I, j minus equals to 1 if all number of grid of ij, okay, so we'll just call it minus equals to 1, and then to check if every element is present or not, I'll just traverse till my ninth element, and I'll check if all number of I is not equal to 0, then I'll simply return false. If negation of check matrix grid, return false. Great, got it. Again, here this should be true. This should be square grid, right? Because the grid that we generated of 3 by 3 matrix, we are calling it square grid. So that's working fine. So what I done over here is we were also given that we need to have only distinct numbers from 1 to 9. So I initialized a vector with 10 elements. So because vectors will be 0 indexed, and I'll ignore 0 for now. So there would be 1 to 9 elements, all initialized with 1. And for all the elements within the grid, which is having 3 rows and 3 columns, because we already generated square grid, I'm just checking if my current grid value is less than 1 or greater than 9. In that case, we won't satisfy this condition, so I'm simply returning false. And we also need to have all numbers. So all numbers would be subtracted. And I'm just checking if we need to have all the numbers, then at all the indices, those values should become 0, because all numbers are considered then only. If any of the value is not 0, or if any of the value is negative, or if any of the value is still positive, then we'll just need to return false, because we aren't having all numbers from 1 to 9. So for I'll just submit this out. So we bet 67 people, person people with our complexity. To to reduce this further, I'll just specify my compiler that I'm not taking in or giving out any inputs or outputs. So I'll just specify my compiler not to load any libraries that are required for performing those operations during compiling. So just okay, it's fine. Actually, now it's not working, but this adding this will fairly reduce our time taken. Fine, thank you. That's it for today.